In the next section, section 11.2, we're going to look at odds. We're going to look at a couple of different types of odds. We're going to start our discussion with looking at odds against. So the odds against an event is a ratio of the probability that the event will fail to occur, right? Failure to the probability that the event will occur, which we're going to refer to as success. Thus, we need to know both probabilities. The odds at horse races and games in Las Vegas are usually given as odds against. So this is something that you may or may not be familiar with. All right, so what we're going to do here is we're going to kind of work through this first one the long way, and then we'll get kind of a shortcut. So as we're looking at this, determine the odds against rolling a 4 on one roll of a die. All right, so first we're going to look for our probability of rolling a 4. All right, our probability of rolling a 4 would be 1 out of 6. And then we're going to find our probability of not rolling a 4. Right, we have 5 other numbers on our die, so our probability of not rolling a 4 is going to be 5 over 6. All right, so our odds against, we're going to do our probability of failure divided by our probability of success. All right. So our odds against, we're going to take our probability of failure, which was our 5 out of 6, and divide it by our probability of success, which is 1 out of 6. Using what we know about fractions, our denominators are basically going to cancel out, so we're just going to get a fraction, but I want to show exactly how and why that happens. So when we divide with fractions, remember that we find the reciprocal or flip that second fraction and multiply. So what we really have is 5 over 6 times, if we flip our second fraction, which is that bottom one, 6 over 1. Those 6's cancel, and we are left with our odds against of 5 to 1. When we're dealing with fractions here, this is a case where we don't want to write this just as a whole number 5. We want to make sure that we keep some sort of fraction or odds against notation. So we are going to say the odds against rolling a 4 are 5 to 1. Oftentimes we see odds written with this type of notation. We see it with a colon in between there. And again, we say it whether we have a fraction or we have it in words, we have it written out with a symbol in between. We're looking at here the odds against, and it's read as 5 to 1. In an experiment with equally likely outcomes, the odds against event E can also be found using the following rule. So what this is it's basically just going to shorten out all that fraction stuff that we did in that previous example. Right? So, all right, using the fact that 7% of the workers in the United States work between 35 to 39 hours per week, what are the odds against a person working 35 to 39 hours per week? Right? All right, so our probability of working 35 to 39 hours is 7%. Our probability of not working 35 to 39 hours. Again, we find our complement by subtracting from 1 or 100%. So we get 93%. So our odds against this time we're just going to take our percentages that we have here, right? 7% divided by 93, or excuse me, failure goes on top because we're doing odds against, excuse me. 93% should go up top. 7% are our odds in favor, the number of outcomes that are favorable. And then we can just get rid of those percent symbols, right? And 93 to 7. This fraction doesn't need to be reduced. Basically, we have exactly the same thing that we saw in our previous example. The only difference is instead of all of that fraction stuff canceling out up there, these really do have the same denominator. They're both 7 out of 100 and 93 out of 100, but we can just kind of simplify, and since we're working with equally likely outcomes, and we can kind of shorten up a little bit of the work that we're going to see. So again, I'm just going to write out a quick sentence here. The odds against working 35 to 39 hours are 93 to 7. So again, odds against, always our number of outcomes that are unfavorable, right? Our probability of failure up top, and then our probability of success, the number of outcomes that are favorable, that's going to be our denominator. That's going to be our bottom number. Again, and then as always, reduce as needed, and make our answers look as nice as possible, and make sure you're entering your answers online in the correct form.